Hello, Algebra. We are back with the last section of Chapter 9. I called this 9.9, but really it's not in your textbook at all. I just want to make sure you have a good understanding of vertex form before we move on to anything else. So today you are going to be able to practice graphing your quadratic functions in standard form, in our new vertex form, and also in factored form. So you know already that the graph of a quadratic function is a parabola. Parabola. There are three. What? Don't worry, we're back. There are three forms of quadratic equations. This first one is standard form. The second one, this is the new one, this is a vertex form. And this last one should look familiar, that is factored form. So just a little review here. If A is positive, the graph opens up, but if A is negative, the graph opens down. Happy parabola, sad parabola. All of our quadratic equations have a vertex, which is the turning point of the graph, meaning it's the highest, the max, or the lowest, the min, point of the graph. It's where the baseball starts going down toward the ground, or it's where the dude on a pogo stick leaves the ground. We also know that quadratic graphs are symmetrical across the axis of symmetry. Which runs through the x-coordinate of the vertex. And the formula for the x-coordinate of the vertex is x equals negative b over 2a. The quadratic function crosses the y-axis at c. In standard form, it would be at c. The y-intercept always has an x value of 0. For a parabola, the y-intercept will be the point 0, c. A quadratic function crosses or touches the x-axis 0, 1, or 2 times. So it has 0 roots, 1 root, which would be the x-coordinate of the vertex, or 2 roots, which would be your 2 zeros of the graph, which would be your 2 x-intercepts. Moving right along, let's identify the parts of this graph. So first we have our vertex, which is green. We have a vertex of about 1, 2, 3, 4.5. Okay, which would make our axis of symmetry x equals 1. The y-intercept appears to be 0, 1, 2, 3.5. And our x-intercepts are 1, 2, 3.25, and negative 1.25. All right, moving on. Graphing in standard form. So we are going to graph the function 4x squared minus 8x plus 1. So the first thing we need to do is find the axis of symmetry, which is the x-coordinate of the vertex. So we are going to plug in negative b, which would be negative 8 over 2 times 4, which gives us a positive 8 over a positive 8, which gives us an axis of symmetry of 1. So we need to find this vertex by plugging 1 back into the original equation. So we have f of 1, 4 times 1 squared minus 8 times 1 plus 1 equals 4 minus 8 plus 1, which gives us negative 4 plus 1, which gives us y equals negative 3. So our vertex is 1, negative 3. And I can put that right here. Vertex is 1, negative 3. It really gave us a lot of room there. All right, so let's identify some key features of this parabola. Our A is 4, B, negative 8, and C, 1. By looking at A, I know the parabola is going to open up because 4 is positive. A is positive. And because it's positive, we know that the parabola is going to have a minimum, because the vertex is going to be below the roots because the parabola is opening up. We also know the axis of symmetry is at x equals 1, which makes our vertex at 1, negative 3, which we already covered. And our y-intercept, you know, is c, so it is going to be 0, 1, because c is 1. And another point on this parabola could be 2, 1, because it is in the same place on the y-axis as the y-intercept, but it can't be on 0 because that's the y-intercept. It can't be on 1 because that's the vertex. So if we go over 1 more, we have our next point. So let's graph all of these parts. We'll start with our vertex, 1, negative 3. We know our vertex is a minimum. Now let's graph our y-intercept, which is 0, 1. There's our y-intercept. Since our axis of symmetry is here, right here, through the vertex, on the x value of the vertex, we know that our next point is going to be symmetrical. So our next point is going to be right here, 2, 1. And now we can graph this parabola. Haha, the magic of online videos. Now you'll never know how many tries it actually took me to get that parabola to look like a parabola. But there you go. You were able to graph your parabola without finding its roots. And now you can pretty much see where the roots are going to be. We're going to have a root at 0, and we are going to have a root at 2. Whoa. Moving on. Alright, why don't you try this one? The first thing you're going to do is find the axis of symmetry, use that to find the vertex, identify all the parts A, B, and C, determine whether or not it will open up, whether or not it has a max or a min, and then find another point that you can plot on this parabola. Pause the video and come back when you're finished. Did you get this for your information? the key features of your parabola? If so, great job. Pause again, graph, and check. And there you have it. Your parabola would look like this. Now let's look at vertex form. This is new. So take a look at vertex form. So vertex form is a times the quantity x minus h squared plus k. And the vertex is always hk. So if you look at this, see here, this is part of the formula. X minus h is part of the formula. So if you see here, that matches the formula. So h is 2. But if you look over here, this does not match the formula. That became a plus sign. That means there was a double negative in there, which means h equals negative 3. Because the only way to get that positive is if you had plugged in x minus negative 3 squared in right there into the formula. I just wanted to point that out before we start moving ahead. Whoops. Alright, let's look at number 1. First, we're going to identify the vertex. The vertex is h and k. So h is 2 and k is 4. So our vertex is 2, 4. Then we're going to identify A. A comes before the parentheses, so A is 2. Number 2, H is negative 3, so our vertex is negative 3, and K is negative 5, so our vertex is negative 3, negative 5, and A is negative 4. And the last one, you go ahead and do that on your own. Pause, and now you're back. Vertex is 1, negative 2, and A is negative 1. Now let's look at this example, and we are going to graph it. First thing we need to identify is A. A, right out there in front, A is 2. A is positive, so we know the parabola is going to open up. No matter what form the quadratic function is in, A always tells us what to do. So the parabola is going to open up because A is positive. And we know because the parabola opens up, the vertex is going to be way down underneath the roots, so the parabola is going to have a minimum. So now we need to find the axis of symmetry. Well, we can quickly identify the vertex here. So let's do the vertex first. The vertex, we know, is 3, negative 4. And the axis of symmetry is the x value of the vertex, so x equals 3. Now, what is the y-intercept? To find the y-intercept, we need to do some math. We're going to plug 0 in for x so that we can solve for y and find the y-intercept. So real quick, that'll be 2 times the quantity 0 minus 3 squared minus 4, which would be 2 times negative 3 squared minus 4, 2 times 9 minus 4, 18 minus 4, and 14. So the y-intercept is going to be 0, 14. So that would make our other point 6, 14. Yes, I realize the graph does not go up to 14. Let's count by 2's.